Hi, I'm Bryan Donovan from the Hudson Republican Committee. And today I'm joined by Joe DeLeo and Art Horn. Joe and Art are both scientists. We're going to be talking about the subject of climate change and global warming. So, gentlemen, thank you very much for joining us. Joe, obviously you're a Hudson person. You're a neighbor of mine. We've been talking for a while about this subject, so I'm glad we're able to do this. Let's start off with a quick bio for both of you guys. So, Joe, starting with you. So you're currently the chief forecaster for Weatherbell Analytics, LLC. And you've been in the meteorology business for 30 years. Let's see, it says here that you were one of the first director of meteorology for the Weather Channel.
That's right.
Down in Atlanta, huh? Okay. You were chief meteorologist at WSI Corporation for over 17 years, which is in Boston, right?
Right.
Okay. You've authored and presented a number of papers and had a book published. I understand that you're a certified consultant meteorologist and was elected a fellow of the American Meteorology Society, the AMS. And you served as a member and chairman of the AMS Committee on Weather Analysis and Forecasting. And you have also co-chaired national conferences from the AMS and National Weather Association. And it says here that you have a graduate degree from University of Wisconsin and a Bachelor and Master of Science. I'm assuming that's in meteorology.
Yes.
And I didn't know this. You were a former college professor at Leiden State College.
Linden
State. That's in Vermont?
Yep. Yes.
So you were a college professor from Vermont. You seem, I didn't know that. You must have escaped Vermont very well. So
early.
Yeah. So Art, Joe, thanks a lot for joining us. And Art is an independent meteorologist for 30 years in the business, basically. You also teach meteorology at Tungus Community College down in the Hartford area. Do a lot of work as an expert witness for lawyers on the subject matter, and do quite a few shows and community topics on
schools, libraries, that kind of thing. Yeah.
Very good, very good. Well, guys, we put together some questions that we're going to be going over. We also have some of the slides that you've put together. We're going to kind of weave that in. So as we go through that, we can reference some of those slides. So let's just start off by, we hear global warming and climate change is accelerating. I actually heard something on the Weather Channel. They were saying this year is the warmest year on record. What's your take on it, and what does the science basically tell you, Joe?
Well, this may indeed be the warmest year on record for the United States, but not for the world. And what is happening is we're in a pattern that's very amplified and very persistent. And we had a very warm first 7 months of 2012 because we were stuck in the pattern where it was cold on the West Coast, but the central part of the country was baking underneath what we call a ridge of high pressure. The same pattern amplified brought brutal summer to the UK, damp, chilly, no barbecues. At the same time, in Russia, they had another heat wave and drought like they had in 2010. So it's a matter of where the jet stream sits up and how persistent it is.
And you got to think about what are record high temperatures. Warmest this, warmest that. Our weather records in the United States only go back to 1895. Mm-hmm. That is 6% of the last 2,000 years. So that means that 94% of all the weather records that you could have compiled over the last 2,000 years are unknown. So the period of record we have for our official records is very short. We have weather records for 1% of the last 10,000 years. So when you say it's the warmest ever this or the wettest ever or that, it's a very short period of time.
Right.
There's one other factor that's involved. Back in 2007, the U.S. National Weather Service, National Climate Center, removed an adjustment to the U.S. climate data that adjusted for urbanization, which we all know is a factor. Everybody knows that the cities are warmer than the rural areas, and so they used to adjust the climate data in the cities down as a result of that urban heat island effect. They stopped that in 2007, and that had a result of pushing down the old data, the old heat records, and pushing up recent data. So yes, this was a warm year and would have ranked in the top 10 warmest years in the United States only. But it probably wouldn't have been number one had they not made that adjustment.
Well, the urbanization, I mean, why is that even a factor? Is it because it's concrete, you've got black pavement, it's absorbing the sun? So it makes sense that urban areas are going to retain warmth.
100 years ago, the thermometer that's measuring the temperature was on a farm. Today, it's surrounded by Burger Kings and highways and all of that infrastructure. That heats up the local climate. It doesn't mean that's representative of what's going on above.
Right, right.
And there's another thing about this record high temperature thing, the warmest decade ever done on and on. Prior to 1999, 1934 was the warmest year in the United States. But after that, if you look at the U.S. temperature record now, 1998 has suddenly gone above 1934. In other words, what's happened is the people who are controlling the weather data cooled the past and warmed the more recent temperatures with adjustments. Now, in accounting, that's called cooking the books. In climate study, you can get away with it. So they have literally changed the past. And now you know what they did with the past? They threw it away. So there's no way to go back and recreate what the old picture looked like. So there's some, you could call it skullduggery, been going on too in this whole thing.
Somebody else had mentioned to me once before, also a weather professional, that 100 years ago you had mercury thermometers that weren't calibrated. Now you've got a digital device that can be calibrated, and that opens the doors for another factor, basically.
Yeah, instrument changes are a part of it too. So, yeah, I mean, you know, the temperature has generally gone up over the last 300 years, but that's happened before in the past. We know that.
And even when you talk about, the like you said before, warmer year, warmer decade, you know, one of the slides that you had, I think the one that we said is the slide number 1, basically compares going back to 1900 to recent, basically. And it's comparing the temperature and also the CO2. So what's significant about that?
That's the global temperature. And you don't hear about this. You'll hear about it's the warmest year ever in the United States. But there has been no warming for 16 years globally. It's been flat, even though the CO2 has gone up 9% in that time period.
Right, right.
From about 1910 to about the mid-1940s, the temperature of the Earth went up, and carbon dioxide was rising. Then from about the mid-40s to the late 1970s, the temperature of the Earth actually fell, and carbon dioxide was rising. From about the late 70s to the late 1990s, the temperature rose. Carbon dioxide was rising. But since then, there has been no warming of the Earth's average temperature, and carbon dioxide continues to go up. So the statistical relationship between carbon dioxide in the atmosphere and temperature is very poor.
Which really is one of the key things, because in that whole argument of man-made contribution to the global temperature, isn't carbon dioxide, wouldn't you think the CO2 would be, that's what man's doing, it's pumping CO2 into the atmosphere, is that
But
correct?
not very much. I mean, carbon dioxide is 3.81% of the atmosphere. It has increased as a percentage of the atmosphere, it has increased in the last 160 years 1/100%. Now, if humans are responsible for half of that increase because of burning fossil fuels, that means humans burning fossil fuels have increased carbon dioxide in the atmosphere by 5/1000%. And this is supposed to cause climate Armageddon.
Right, right. I guess the flip side of that would be if humans stopped doing that, would we, would the temperature regulate at the perfect temperature?
There is no perfect temperature.
Well, that's another thing, right? Now, one thing I want to say is that we're going to talk about a lot of the slides, and we're going to show that as part of our program here. We're also going to actually have a document that has all the slides, because there's quite a few that you have put together, and our questions, and we're going to have that on our website, which is HudsonRepublicanCommittee.org. So anybody that's watching, if you want to get more detailed data, you're going to be able to do that. We'll have that on our website, and probably within the next couple of weeks we'll be able to have that. So anyways, let me Art, this was a question that you had mentioned before. Shortly after Hurricane Sandy, which recently occurred, Michael Bloomberg, the mayor of New York, happened to endorse President Obama right before the election, and because of his stand on climate change. What does that endorsement mean to you?
Well, I mean, right after the storm, it was a terrible event, of course, and Mayor Bloomberg decided to throw his recommendation to President Obama because of his stand on climate change. What that said to me was, well, does he actually think that by electing President Obama that his policies are going to allow him to change the weather? That's medievalism. I mean, not far from here, a few hundred years ago, when things went bad, they used to burn people. Is that where we're going now? I mean, we actually think that because if we pass some kind of legislation that we're going to be able to change the weather?
Well, why is the weather even a political matter in the first place?
Well, it's all gotten tied into this global warming thing. See, it used to be we just had weather. But now, every storm, every tornado, every hurricane, cold wave, snowstorm, everything is caused by global warming. And it's becoming more and more and more of that. I can't say exactly why that's happening, but that's what it is.
Some of that has to do with the fact that it's not warming. They can't say global warming anymore. They don't talk about global warming. They talk about climate change now, right, and climate disruption and extreme weather. What's causing all of these extremes, we have to do something about it. They're not talking about global warming anymore because it's not warming.
Well, when hasn't that climate changed? I mean,
there was exactly.
Always.
Yeah.
In 1781, I believe it was, Thomas Jefferson was lamenting the fact that the rivers that used to freeze solid don't do it anymore. The snows that used to lay deep on the fields through the entire winter don't do that anymore. He had noticed that everything had warmed up.
For 28 years.
For 28 years. He was noticing one of those warm cycles that continue to happen today.
Well, Joe, you actually even have a slide, it's that AMO slide, which kind of talks about that a little bit.
Right.
So how does that slide, what is that telling us, and how does it relate to the whole Hurricane Sandy discussion?
Well, last year we had Irene, this year we had Sandy, and they're saying, boy, storms like that back to back.
Unprecedented.
It must be global warming. The Atlantic goes through cycles of 30 years warm, 30 years cold, 30 years warm, 30 years cold. And when the Atlantic is warm, it's warm in the tropics. There are more tropical storms, more landfalls along the East Coast, especially when the Pacific goes through cycles too. And they're not exactly in sync. When the Pacific is cold, we have more what we call La Niñas, more cold events. And when a La Niña and a warm Atlantic work together, the East Coast is in trouble. Back in the period, the last time the Atlantic was warm, from 1930 to 1960, we had 9 landfalling storms. The hurricane at 38, 44, Carol, Edna, and Hazel in 55, Connie and Diane in 54, Connie and Diane in 55, right, and Donna in 60. Right. And everybody was saying, my gosh, the East Coast is under assault. When is this going to end? Well, it ended in 1960 when the Atlantic turned cold.
Cooler. And from August of 54 to October of 55, New England was hit by 5 tropical storms, 2 hurricanes, 1 direct hit by Carol in 54, and then literally like 10 days later, 11 days later, was Edna that hit Cape Cod. So we had 2 hurricanes in 11 days. Can you imagine if that happened today? What people would be saying? Well, it's climate Armageddon.
Right. So it's not unprecedented, and actually it's right in that cycle. Because I think that's what that AMO slide is really telling us.
And since it's likely to stay warm for another 5 years or so, we are still vulnerable.
Right.
Just like we were at the end of the last warm cycle. So I wouldn't be surprised if next year there's another hit.
Watch
Maybe
out.
it's not Long Island or New York City. Maybe it's Cape Cod or Providence or
But on the other hand, New England could have a
Bay.
Category 3 hurricane next year. And you think Sandy was bad. If New England has a Category 3 hurricane moving at 50 to 60 miles an hour, you are going to see destruction that you will not believe. It's going to make Sandy look like a picnic.
Well, you mentioned before the angle that Sandy had as far as landfall is concerned. That's a factor as well.
When you go through an intersection and another car misses the light and T-bones that car, that's what Sandy did. Sandy came up and hit the coast perpendicular. That's a lot different than going north-south. When the hurricane comes up the Jersey coast, from south to north, all the strong winds and storm surge are out over the water. When it comes in a T-bone, all that storm surge and strong wind smashes right into the coast, and that's what happens.
So it's not only the category,
Right.
it's the angle of attack
It's the
almost.
angle of attack that makes a tremendous difference.
And most storms, by the way, do what Sandy did, which was become what we call extratropical.
Broader.
They transform from a tropical storm, very tight and very intense, into a bigger, broader storm that's cold and produces a lot of rain. But usually it's out over the North Atlantic. What was unusual about Sandy is that there was a big blocking high pressure over eastern Canada, and it couldn't go that way,
Right.
so it made a left turn and went into New
Well,
Jersey.
I remember people talking almost like that perfect storm type of scenario. There was that other system that was out, like you
Right.
said, I guess it was, in maybe the Canadian maritime area and just kind of held it there. So, we just talked about the frequency, and the frequency is, get ready for it because according to this AMO slide, we're in that range again.
Right.
And then we also talked about the damage. And people are talking about the fact there was a superstorm or so forth because of the climate change and what have you. The data doesn't really indicate that.
It wasn't. It was not a superstorm. The media called it that because they liked the sound of superstorm. It sounded good. The reality was it was Category 1 on a scale of 1 to 5, 5 being the biggest. It was, in fact, New Jersey, New York City, Long Island, Connecticut, Rhode Island, Massachusetts had no sustained hurricane force winds of 74 miles an hour or higher. It was actually an average to smaller than usual hurricane in terms of the hurricane force winds. It just had a very large wind field of tropical storm force winds and the angle of attack. But it was not a superstorm.
And carried a mound of water with it, and it came in at the absolute
Right,
worst
worst
time.
time.
Yeah,
high tide,
Full moon, high tide.
full moon.
Right.
In 1821, there was another storm that hit New York City that was a Cat 3. That came up from the south, not from the east. It had the old record for storm surge at the Battery,
Right,
11.2
right,
feet.
Right. At low tide.
But it came in at low tide. They say if that storm had come in at high tide, it would have made a 5-foot difference. Now, the sea levels were about a foot lower then because we were coming off the mini ice age. So it would have been 17-foot storm surge.
Right.
This storm surge with Sandy was 14,
14, almost 14, yeah.
feet. So it would have been worse in 1821, long before CO2 was even
Thought about it.
Right. Well, we talked about hurricanes, as it relates to other, extreme weather events, droughts, floods, tornadoes, heat waves, and so forth. What does the data tell you, and how do you explain what the cycle is right now on that?
Well, there's been no trend long term in droughts or floods going back to 100 years in the United States. Now, we do see them to cluster. The 1930s, we had the Dust Bowl years, 8 or 9 very, very dry years where crops failed in the central part of the country. Again, in the 1950s, we had 7 or 8 drought years. But then you have wet years, and then we had a couple of drought years in a row now. We may see another one. Again, that relates to the Atlantic being warm, and when the Pacific is cold, we tend to have Midwest droughts.
Same thing with precipitation. I mean, if you look at the precipitation in the United States for the last 40 years, there's zero trend.
Right.
There's no upward or downward trend in the last 40 years. And this is when carbon dioxide is supposed to be causing all these terrible problems. But in terms of extremes of weather, the weather happens because it's cold at the top and the bottom of the world, and it's hot in the middle, and the whole thing is spinning. That's what makes the weather, the temperature difference. So the greater the temperature difference between the poles and the equator, the more weather you're going to have. So when you look at the ice core drilling, so we can drill into ice in Greenland and using isotopes of oxygen as a way of representing temperature in the past, you can go back 425,000 years into the past and see the last 4 ice ages. And what you see is that during the ice ages, when the Earth is much colder, that's when the temperature varies the most. During the warmer time, where we are now for the last 10,000 years, that's when the temperature has varied the least. So the data says that extremes of weather are much more common and much more extreme when it's cold on Earth than when it's warm.
And we're very fortunate to be in one of those climate optimum warm periods.
Right.
These ice ages last 100,000 years. These little interglacial periods last 10 to 15,000 years, with 10,500 into this one. At some point, it's going to end, and there's going to be some dramatic cooling. We're talking over 10 degrees.
Right. And some people will say, well, if the temperature warms, then you have increasing moisture in the amount of air, and that causes more extreme weather. But not necessarily. You can have a foggy day, 100% relative humidity, and it doesn't rain. What you need is something to lift that moisture to produce condensation and then produce precipitation. So if in a warmer world you have less temperature contrast, the storms are weaker. So you could have more moisture, but there's nothing to lift it. Not as much to lift it. So if you can't lift the moisture, you're not going to get increased precipitation.
Right, right. And I think we have a couple of graphics on the ice core data, and you know, that'll be in the report as well. So I think the thing that you were saying, Art, was that as far as the amount of variability, it really is significantly greater. And that really, the ice core, I mean, that's a way, I mean, you had mentioned before, we really only have good data going back to 1900 or 1890s. Now you look at something like an ice core, which gives you several thousand years as a reference point. Now you know, from a scientist's point of view, it tells you a little bit different story.
Right, right. As Richard Feynman, the great scientist, used to say, no matter how beautiful your theory is, no matter how much you're in love with it, no matter how much you think it's true, if it doesn't stand the test of reality against experimentation and what happens in the real world, the theory is wrong and should be abandoned. And that's man-made global warming.
That's right.
Now, you know, we talked about the ice core. It kind of brings us into the next question, and there's a great slide in here. There was a lot of discussion about snow. You know, the snow. I think there's actually one of, we say in the document, was it back in 2007 that somebody made a prediction that, you know, snow is going to drastically, you know, kids aren't born in that year, might never see snow or something.
It started at 2000
right.
in the UK when they said the snow would become very rare.
Rare and very unusual event. One of the doctors, Dr. Viner from the University of East Anglia Research Division, Climate Research Division, said a bold prediction. We just, very soon, we're not going to see the snows that we have seen in the past. They've been buried.
5 years
They've been buried.
of significant snows now in the UK, and they're getting it again today as we speak.
You see, a lot of these climate scientists are very good at manipulating equations and doing research. They have no experience in forecasting.
Right.
So they believe everything they see in their computer models and think that their models are always going to be right because they have no forecasting experience. They have no more forecasting experience than a college freshman in a meteorology program. Right. So when they're wrong like this, they're probably shocked. I can't believe it. But they've been nothing but wrong.
And you mentioned 2007. There was this meeting on top of Mount Washington of the Union of Concerned Scientists making the presentations in front of the ski areas, all of the ski areas from New England, the maple sugar industry. And they said, because of global warming, your industries are in great jeopardy. You will see much less snow. The maple trees will be packing up their bags and going into Canada. Get out of while getting is good. Well, it turned out that winter, 3 months later, 2007-8, turned out to be one of the snowiest winters on record, setting records all across northern and central New England, all across the Rockies, and all the way up to Alaska.
Probably the best ski season we had in a long time.
In a long time.
Right.
In terms of coverage of snow in the Northern Hemisphere, the winters of 08, 9, 10, and 11 were the 4 snowiest consecutive winters in the last 45 years in the United States and in the Northern Hemisphere. I mean, it's just gone exactly the opposite from what they've said.
Well, you just mentioned they're not really in the business of forecasting weather. And actually, we were talking a little bit before. I mean, you guys you're in the private sector as meteorologists. I mean, if you did a presentation in the fall or winter of 2007 and said we weren't going to have snow, and that same season was the snowiest, one of the snowiest of record, you probably would be out of business.
It's not good for business.
It is definitely not good for business. So the fact that you got these, private sector guys like you, and then public sector guys that are, kind of have a different agenda. I mean, they're making a living differently.
Right.
They're not making the living the way that you guys are doing it.
And they tend to want to avoid making really short-term predictions. They like to go out 100 years from now. And I can make you a bet 100 years and double your money if I'm wrong,
Right.
I bet you there'll be weather in 100 years.
Yeah, they're going to get paid. They're going to stop having paychecks 100 years from now for those folks making those predictions.
More than likely.
Yes, more than likely. So, anyways, now one of the other slides that we have in there, I can't remember what we had, but it basically had by a decade the snowfall. 1960 happened to be a big year, and then you can see the trend that we're in right now. And as we were talking about this before, and my wife, same age as I am, basically says the same thing. I can remember when I was a kid in upstate New York, we had, Lake Champlain was frozen. You could drive a Mack truck on it, and we had 10 feet of snow, and so on and so forth. And you hear a lot of people say that, our age, basically.
It was a colder period.
Yeah.
Yes.
There's no question about that.
But on that graph, you can see 1960s, the 60s really stand out. Then it kind of goes down.
Right.
And now we're kind of trending back up. And as you said, I think for the last,
5 years, 4 of the top 5 years of snow for the Northern Hemisphere have occurred in the last decade.
Right.
Well,
so
in 4 years in a row.
And since around 1998-2000, United States winters in every region in the country are getting colder and snowier. Mm-hmm. Now, last year was an anomaly. This year we'll probably go back to the long-term trend. The winters are getting colder and snowier, and that has to do with the oceans, the ocean cycles, which have changed. The Pacific Ocean
It's turned cold.
was warm from the mid-40s up into the middle 70s. And now, or is that,
No,
it
it
was
was
the opposite.
cold.
It was
Yeah.
cold, right. And then it warmed from the mid-70s to the roughly late 90s, and now the Pacific is cooling again. And the Pacific, being the biggest ocean in the world, has a big impact on the global temperature. And that's what we're seeing. We're seeing no warming. And in the United States, the temperature is falling.
Right.
And we've had 17 major impact storms for the major cities of the East since 2000, out of the 46 that they've tracked since the 1950. So we can see, and the 1960s was the big decade, but we're just 3 years into this decade, we're catching up to 1960.
Yeah. Well, one of the pictures that you have in the slides must be a sign outside of a church, and someone saying, "Whoever's praying for snow, please stop," which I thought was pretty funny. Art, you had talked about the hemispheres aspect of it recently. So, and this is something that we were talking about before, but you've got the northern hemisphere, you've got the middle zone, and you've got the southern hemisphere. What role do they play in the overall picture, and what's the data saying as far as global warming in those three zones?
Well, I guess most of the warming has been in the northern hemisphere. Right. The oceans in the southern hemisphere, most of the southern hemisphere is ocean. If you tip the Earth upside down on a globe, there's hardly any land. It's like 15% is land. It's mostly ocean. So that really modifies the climate of the southern hemisphere tremendously. Even though, on average, the southern hemisphere is a little cooler than the northern hemisphere. That's because of Antarctica. It's so incredibly cold. But most of the warming, what there has been in the northern hemisphere. There's more land,
right,
which the sun heats up,
and the Arctic. Not much warming in the tropics. You can't find it in the lower levels. You can't find it high up in the tropics, where all of the climate models said there should be a lot of heat. You can't find it in the Antarctic, where those climate models said there should be tremendous warming. You can't find it in the Arctic and in the northern hemisphere. On the land, a lot of that has to do with that Atlantic cycle. When the Atlantic is warm, the Eurasia is warm, and the eastern parts of North America tend to be warm on an annual basis, so that's contributing. But urbanization in the northern hemisphere is also contributing. That's where most of the cities are.
Growth of cities around thermometers.
When the Atlantic is warm also, the Arctic is warm, because the Arctic ice floats, unlike the Antarctic ice, which is sitting on land. And what happens with the Arctic ice is both the water from both the Pacific and the Atlantic flow into the Arctic underneath the ice, and when the oceans are warm, it's warmer water coming in, thinning the ice. When the oceans are cold, there's less melting, and the ice thickens more in the cold seasons.
Well, a lot of people will say, and I think there was maybe Al Gore made a famous photograph of a polar bear up, ice receding and so forth. And I think what you're showing in the document, anyways, back in the 1950s, was it a U.S. sub that went up in
the skate? The skate surfaced, I think it was 1959, at the North Pole, right at the North Pole.
Right at the North
Pole. And there was a foot of ice at that particular time. Now, you can't do that today. The ice at the North Pole is roughly 7 feet thick. So you can't get through the North Pole, but in 1959 you could, because that was at the end of the 30-year warm period of the Atlantic, from the 30s through the 40s and 50s. Then in the 60s, 70s, 80s,
that ties back into the AMO slide.
That's what it is.
Exactly.
That's what it is.
The Atlantic temperature was high at that point, and it's the same thing now.
In 1916, you could ship coal in and out of Spitsbergen, which is at 80 degrees north. It's part of Norway, way up north. You could ship coal in and out of Spitsbergen in 1916 for about 75 days. By 1938, it was up to 170 days. The Atlantic was warming. The ice was receding, just like it is today. The cycle was in the warm cycle. Then, in the 1960s, 70s, and 80s, and into the 90s, the water was cooler, and the ice expanded. See, the thing about when you look at these pictures of Arctic ice, our period of measurement starts when there was the most ice. The Atlantic was cold. In 1979 is when we put up polar orbiting satellites. That's the first time we could take a picture of how much ice there was. So in 1979, there was a lot of ice because the Atlantic was cold. And you look at the ice, it was very stable until about the mid-90s, when the Atlantic warmed up, and then the amount of ice started to decrease again. Now that's leveled off. The amount of ice is basically leveled off since about 2006. And it will continue to be relatively low until 5, 10 years, who knows how many. Exactly, the Atlantic goes colder, and the amount of ice in the Arctic will start to increase again. It's a cycle.
So the natural cycle will change.
Will take over.
And meanwhile, Al Gore's polar bears are doing just fine.
Everywhere.
They are record numbers, according to Mitch Taylor, the foremost expert on
and the I can't remember his exact title, but the fellow in Alaska who is in charge of their environmental programs has said that the polar bears are at an all-time large number of abundance. They're everywhere. So they're not drowning. They're not going extinct. They're everywhere. And everybody's, when I go out and speak to people about this, they're shocked. They can't believe it. What about the polar bears? Oh, they're everywhere. Yeah. And they're also shocked to find out the temperature hasn't increased since 1998 or so. They can't believe it because they've never heard it, because you never hear it anywhere.
Right. Well, people, I think I might have mentioned this to you, Joe, before. I was at a town hall meeting with Charlie Bass, would have been 2011, who was our U.S. congressman from our area. And a woman behind me got up and she basically said, "Well, I can't sleep at night because this global warming. I've got a son, he's 20 years old. What are we doing to our planet? It almost felt like she was saying, the end is near. But the reality is, when you look at the data, there's a cycle. If the data tells you basically that's what's going on, because that's exactly what we're doing. But yet there's people out there, like this picture of Greenland that you have. They happen to take an image of it at the right time. Why don't you tell us a little bit about the details of that, Joe?
Oh, that was great. That was mid-July this year. They have a satellite that has a sensor that looks at the brightness, the albedo that we call it, and it depends on the state of the water, of the ice. When the ice is frozen, it's very white and very bright. If there's any kind of melting and there's a little bit of water mixed with the ice, the
it's not as reflective.
It's less reflective, and they depict it as a rose color. And suddenly, in these 3 days, the temperatures at the center of the Greenland ice cap, which, by the way, is 1.2 to 1.9 miles thick, 1 or 2 inches of the snow at the top partially melted and changed the color. And the media went, oh, the Greenland ice cap has disappeared.
That's what they said. It's melted. It was essentially like the Zamboni going over the ice rink between quarters, melting and resurfacing the top. That's all that happened.
Well, if the ice is well over a mile thick, taking a photograph from outer space is supposed to tell you what? I mean, what is that telling you?
It just showed the very surface. It doesn't tell you anything more than that. It just showed the very top. The temperature got above freezing for a few days. There was some melting right on the surface. After that, the temperature went below freezing, and it all froze again.
So, well, this is the type of thing. A lot of people, in good intentions, whatever, but they hear that type of information, and obviously they're going to be very concerned.
Harry Truman said a long time ago, and I can't quote it exactly, but I can paraphrase it. He said something to the effect of, "I feel sorry for the poor bleep that listens to the news and reads the newspaper and then thinks he knows what's going on in the world." And it's the same thing when you watch these news programs. They're going to tell you what they want to tell you to make a dramatic news program. It doesn't mean it's the truth. It doesn't mean they're lying. It just might mean they're not telling you the whole story. That happens all the time.
And then they jump on it and say, well, that's proof that Greenland is melting. If it hasn't entirely melted, it surely will soon. And that's going to cause sea levels to rise and flood the coastal cities. So we need to go ahead with our plans to deal with that along all coastal cities.
We're not seeing that, are we?
No. Sea levels
isn't rising any faster than it has been for the last 100 years.
It has decelerated. In fact, it fell from 2010 to late 2011, and it concerned them so much, they rushed around to figure out how can we display this. This is going to look really bad if we see the sea levels falling. So they made an adjustment. They called it an isostatic rebound adjustment. They said, well, 10,000 years ago there was a glacier on the land, and it has retreated, which means the land is probably rebounding. So we'll make an adjustment for that rebound. And instead of a decrease in the sea level, they brought it back up a little bit.
Well, the fact of the matter is, too, that when you're talking about sea level rise, it's not rising everywhere.
No.
It's falling in some places. That's because the land is doing different things.
Right.
In some places, the land is sinking, accentuating a sea level rise in that location. In Juneau, Alaska, sea level is falling at like 50 inches per century because the land is rising rapidly. So it depends where you are.
In mid-Atlantic, the land is sinking.
Subsiding.
By the way, the NOAA says that their estimate of sea level rise is 1.6 millimeters. Now, that corresponds to 6 inches by 2100. If you remember in Al Gore's movie, that he used this big crane in the studio to go up 20 feet to show you, he said, by 2100, we'll be up 20 feet, our sea level. See how high that is. And Hansen has said 240 feet.
Some crazy number.
Some number like that. Well, in 6 inches, he could have used the New York City Yellow Pages and stood up on the Yellow Pages and been more accurate.
I never saw an Al Gore movie, so
well,
I feel sorry for you guys.
He took two science, when he was at Harvard, he took 2 elementary science courses, and he got a D and a C.
Yeah. But that was before he invented the internet. So
right,
anyway.
Which greatly accentuated his degree of ignorance.
One of the things that people hear, and I know I hear this all the time. The science is over. The decision is over. There's no discussion. There's no argument.
It's over.
And that really, obviously, when you look at the data, it doesn't. How can somebody say that?
Well, the way to avoid discussion of something is just to completely avoid the subject altogether. Just to pretend it doesn't exist and move on. Many of them will not discuss the issue because there is conflicting evidence, a lot of it. These surveys, the people say 97% of all scientists believe in the consensus of man-made global warming. Well, most of that is based on a 2009 study from the University of Illinois where they sent out an online survey to some 10,000 scientists.
Right.
They got about 3,000 responses, and there were 2 questions. And then they whittled down the answers to the 2 questions from the 3,000 to like 79.
79 scientists that had published on climate science. They decided on 79 scientists, and then they asked them 2 questions.
Two questions. One was, do you think the temperature's gone up?
Since 1800, the Middle Ice Age.
Okay, yeah.
Art and I would have said yes to that.
Yeah.
And then they said, do you think humans have had a significant impact on it? Well, what do you call significant?
I'm not even sure they said significant. Does man have an impact on climate change?
I think the word significant was in there, but
even what is significant, though?
Well, urbanization alone would have a
local factors.
Just building a house,
changing
the black
land
roof. Yep.
from forest to farm changes the local climate. There's a lot of different things that, and the degree of significance, is it 50% significant? Is it 10%? Is that significant? So that question was rigged to give a yes response as well. And then, of the 36 meteorologists that responded to the survey, only something like 64% said yes to both questions. So they threw out their results altogether.
So the survey wasn't just to meteorologists?
No, it was to all different kinds of scientists, 10,000. And then they got 3,000 responses. So no, it wasn't just climate scientists and meteorologists. It was to a wide variety of scientists. Yeah. So they chopped it down to, they handpicked who they wanted for the response to get their 97%. So it's bogus.
Mm-hmm. They like to get these big numbers. 97% of all scientists agree. If you don't, well, you're not a good scientist. About which Michael Crichton said the claim of consensus is the last refuge of scoundrels. It's an attempt to claim the science is settled to stifle debate, and basically that's what they're trying to do.
Right.
There are thousands of scientists who do not believe in man-made global warming. There are over, 30,000 that have signed the Oregon petition. That's just, and some 9,000 PhDs in that list. So there is no consensus.
Right.
There may be a majority that believe in man-made global warming, but there certainly is no consensus.
There is a majority of those that are getting government grants to study climate change that will endorse it.
That's how they get their paycheck, so I could see that.
Absolutely.
Last year, the federal government doled out something like $9 billion in funding to 16 different federal agencies to study the problem. That's a lot of careers and nice cars and big houses and college educations. Right. If the whole man-made global warming thing went away and the government didn't need to spend that money on that, think about what would happen to those people.
Well, they're talking about the fiscal cliff that we're about to go over, and that's just adding to it, basically. Now, Joe, you had mentioned before, what does the UN do in this space, and the
UN was charged back in the Club
late
of Rome,
80s.
Well, late 80s, yes, to start looking at this issue, and this will be the 5th report that's coming up next year. And not to find out whether there's global warming, but basically to study what we can do to deal with global warming.
What's the man-made influence? It was never about does human activity affect the climate. It's how much.
And
it was assumed that automatically that people were causing global warming.
And how bad the results will be from it.
Right.
The consequences.
Right.
And they make statements like we have 95 to 99% certainty. That, in fact, those numbers are in the next report already. We've seen early cuts. 95 to 99% certainty that man is responsible for significant, potentially catastrophic global warming, based on our models. Now, in their models, if you look at their models, the climate models, many of the major factors like water vapor, clouds, solar, ocean, air, atmospheric interaction, they rate their understanding as low or very low. So how can you trust a model on which some of the major factors that affect the results you have very low confidence in? The output from that at a 95 to 99%
Right.
degree
Well,
of certainty. It
if
doesn't
the-
make sense.
If the statement is based on their models, that it's almost meaningless. Because I go back to that very first slide that we talked about, which has the CO2 rising. It's got the temperature basically laying still. And Art, there was another slide I think that you had where the real last maybe 5 years or 10 years is almost totally flatlined.
It is flatlined. It hasn't gone up at all in the last 15, 16 years, depending on your measure. So there is, and that's going to continue. It's going to continue for another 10, maybe 20 years. The temperature is not going to go up. It may actually start going down.
The solar influence exerts itself. Right?
The sun is becoming weaker. The number of sunspots during the last solar minima was pretty spectacular in terms of how there were none. And the astronomers are saying that this cycle we're in now of the sun, which is very weak, they're saying that sunspot cycle 25, the next one after this, may not happen at all. And that could mean some big changes in the solar wind, could mean changes in the cosmic ray concentrations, which may have a big influence on the amount of cloud cover on the Earth. And we could see a protracted period of global cooling. That's what the Russians are forecasting. The Russian scientists are saying we are going into a period of protracted cold weather.
Already the Pacific is cool. The Atlantic is warm, but it's near the end of that warm cycle. If it goes into its cold cycle and the sun goes to sleep, we have all three factors that affect temperature leaning toward cooling. Right. So you could expect temperatures to fall rather significantly.
Well, actually, the last question I have here is kind of ties right into that, because a lot of people are looking at, maybe Europe and China being a little bit farther ahead as far as solar and wind power. And why doesn't the United States invest more heavily in those technologies, and also the whole carbon tax and schemes that they've come up with plays a role in that as well. So I mean, looking at it from a scientific point of view,
wind is not new. It's been around since the 80s, 1880s.
Yeah.
The wind solar has been around since the 90s, 1890s. Now, if these were viable energy sources, by now, there'd be more than 2% of meeting more than 2% of our energy needs. They require heavy subsidies. Now, they talk about Europe as the model. Mr. Obama, in his campaign in 2008, used Spain as his model. Well, in Spain, they invested very heavily in wind and solar. Every wind job cost $770,000 to create. Solar jobs cost $1.3 billion. For every green job created in Spain, they lost 2.2 real jobs. Now, of those green jobs that were created, only 1 in 10 were permanent. Because once you build the wind turbines, they don't need these contractors to stand around and watch the wind turbines turn.
Right. And the sun doesn't always shine.
The sun doesn't always shine.
Wind doesn't always blow.
So what happened?
You got to build a traditional power plant to back it up.
Exactly. Right. What happened? Unemployment in Spain went to 25.5%, worst in the world. Their economy went into the tank. Industry fled. They stopped the subsidies. They're getting out of the wind and solar business.
Right. They learned a lesson.
They have to.
But we think we're going to somehow make it successful, even though Spain failed, Italy failed. The UK is getting out of wind and solar and building coal plants as fast as they can because they have between a quarter and half of the people in the UK are in energy poverty, which means in the winter they can't afford to pay for fuel and food. They have to decide on which.
Well, guys, that kind of pretty much wraps it up for us. And I think we covered a lot of things. We didn't quite go over the questions that we had, but I think we kind of tied in a lot of the stuff that we had in the slides and so forth. So I really appreciate you. Art, thanks a lot for driving up from Connecticut. And Joe, thanks a lot for sharing your information.
Thank you,
it was greatly appreciated.
Great.
And I'd like to thank everybody for joining us. I'd also like to thank the folks here at Hudson Cable TV that always help us out, Jim McIntosh and Scott Pearson. Thanks a lot, guys, and thank you very, very much for joining us.